So in this tutorial, I'm going to be taking you through the nomenclature of organic compound part 2, and I'm going to be starting with the unbranched hydrocarbons. So when we say hydrocarbons, we mean this compound only includes strictly hydrogen and carbon. And if I said it is strictly hydrogen and carbon, it means no other element should be found there. That is what I mean by saying that. Alright, so as you can see on the board, these are some organic compounds that we are going to name together. But before that, I want to quickly discuss something that is very, very vital. So if you look at the uppermost part of this board, you are going to see that I write 4 carbon bonding to themselves through a dashed line. And I write a very simple word up there known as what? Catenation, if you can see it very well. So what is catenation? Catenation is the ability of carbon to bond with itself. So this carbon bonding to this carbon, and this to this, and this to this, is known as catenation. Now, these are 5 selected questions on naming. This compound that you see on the board are represented by a formula that we call condensed formula. This is not how a structural formula look like, but most of your test and exam questions will ask you to name a condensed formula. So, and it's always tedious to name a compound while it is condensed. So the most accurate form of naming this compound is when you show their full structure. So condensed formula is also a structural formula, but the most very, very crucial structural formula is the one that we call the dash line structural formula. Dash line, dash line. This is the spelling. So, but the one you have on the board, 1, 2, 3, 4, 5, is what we call the condensed. We have condensed it. Alright, so our focus in this tutorial is how to interpret a condensed formula into a structural formula, dash line structural formula, and how can we name the compound. But before we continue, I would like to talk about 1, 2, 3, 4. Alright, now let me tell you something that you have to know. In every organic compound, there's what we call terminal carbon, and there's what we call the internal carbon. So in every organic compound, there are 2 carbon that exist: the terminal carbon and the internal carbon. The terminal carbon are the carbon that are located at the edge, while the internal carbon are the carbon that are located within the chain. So for instance, this particular carbon, the one I'm putting my arrow to, they are terminal. Why? Because to the left, this carbon is a terminal carbon, and to the right, this carbon is at the extreme end. But these 2 that we just box at this middle with my black marker, these 2, they are both internal carbon. Because of that, the first organic compound that we know is alkanes, and they are known to be saturated. And when do we say a carbon atom is saturated? When it is able to bond 4 bonds. So if every carbon atom is able to bond 4 bonds in this organic compound that we don't know who it is, then we can say the compound is what? Saturated. So this is it. Since this carbon is already having 1 bond in the chain, that means for every terminal carbon, for them to be balanced, they must have 3 hydrogen, because every carbon atom must bond 4 bonds. For a carbon atom to be saturated, it must bond 4 bonds. So this is already 1 plus the bond from these 3 hydrogen, that make it 4. While this one is 3 already plus the bond inside this chain, that make it 4. That means these 2 terminal carbon are saturated. Now for the internal, since the internal is already having 1 bond from here, 1 bond from here, like a front bond and a back bond, so they already have 2. So it's not right for us to say they will need 3 like the terminal. So any internal carbon is always taking up 2 hydrogen, while the terminal carbon always pick up 3 hydrogen. Now coming to this, whenever you see a compound that obey this rule, then that compound is saturated. So therefore, if you check my example 1, you notice that this is CH3 and CH3. That means the terminal are existing in the right manner, while the CH2 are the condition for the internal carbon, and they are obeying that. So it means that this compound is saturated. Therefore, it's not hard for you to name it. Just count the longest chain. 1, 2, 3, 4. You know this is unbranched. There's no need for naming any attachment. Just count 1, 2, 3, 4. Since it obeys all the rules, then that will be. You have to remember the Greek naming I taught you in my previous video. I said boot is suggesting 4 carbon. So 1, 2, 3, 4. That's boot. Then you say butane. All right. Now for the second example, you see that this is CH2 and this is CH. So a terminal carbon should not be CH2, as I told you. A terminal carbon should be CH3 under normal condition if it is an alkane. So seeing that this guy is lacking one hydrogen that's supposed to be CH3 at the edge, it suggests to you that this compound is not an alkane anymore. So therefore, the best way we can do that is that you are going to show the structure. So showing in the structure, you are going to put some lines, a dash line, so that you show how they are bonded. So if you check, this CH3 is balanced. 1 bond plus 3, that's 4. 2 here, 1, 2, 4. But for these two guys, they are both not balanced. This one is only having 1, 2, 3. While this one is having 1, 2, 3. So for us to balance it, we have to put a double bond. So by so doing, we know that this compound is not an alkane, not allowed, is not obeyed. So therefore, I'm going to now say this is an alkane. So how do you name this compound? Very, very simple. That means there's a double bond here. So a double bond must exist here because there is an anomaly. Something is wrong, okay? Now, because of that, you will not name this compound butane. It's still but because it's 1, 2, 3, 4. So it will be but, but the ending name will not be ane because this is unsaturated. It's having a double bond. And any compound that have a double bond belong to the alkane homologous series. Alkane, E-N-E. So therefore, this compound will be, if you come from here, 1, 2, 3, before we see the double bond. So that will be but 3 in. But if you come from this left-hand side, 1, you have seen the double bond. So in this organic chemistry, we go with the lowest possible side. So we are going to prefer this side because it's a shortcut than this side. So therefore, this compound will be but 1 in. And please, not but 3 in. You cannot count from here, 1, 2, 3. No. Rather go to the other side and count from here. Always check both sides and look for the possible lowest side that can give you your double bond. So the compound here is but 1 in. So how do we name this one? This one is CH3. Whenever you have a particular element inside a bracket and there's a subscript, it means you are going to write that particular thing that you have in the bracket twice. So this will not give you CH3, CH, CH. It means you should write CH in 2 places. Then CH3. You notice that I told you that any internal carbon must be CH2, CH2. But you notice that these two, they are not CH2, CH2. That should tell you that this compound is not an alkane. It's having a double bond. So that double bond, by the time you put double bond, this will be 1, 2, 3, and there's another one between carbon to carbon, that's 4. Therefore, this compound will be an alkane. If the hydrogen is lacking 1, 1, instead of 2, 2, that's an alkane. So how do you name? If you come from this right-hand side, 1, 2, you have seen your double bond. From the left-hand side, 1, 2, you have still seen your double bond. That means this compound will be best known as but 2 in. Because the position of the double bond is at carbon number 2. So this compound will be best known to be but 2 in. That's how you name this. And now let's go to this. If you check, the CH3 here is correct because I said all terminal carbon must have CH3. And this one, CH3, correct. But this CH2 is also correct because all internal carbon must have CH2. But these two carbon, they don't even have any hydrogen at all. You know, these two, they even have 1, 1. That's why they are in. Now, if you have two carbon that are not having anything at all within a chain, that is an alkyne. So therefore, the correct structure that this is supposed to give you is supposed to be CH3, CH2. So those two carbon, they are going to share triple bond and then CH3. So this should tell you that they don't have anything. So if there's no hydrogen at all, that's an alkyne. So you are not going to check on both sides. Please make sure this is your left and this is your right. Don't rush when it comes to naming your organic compound. Make sure you observe well. In fact, as a scientist, you cannot survive unless you are observant. It's only people that observe that survive in science world. Make sure you are not rushing, be calm and observe. So check from the right, 1, 2. Check from the left, 1, 2, 3. So which one is longest? Here. So we are going to prefer to come from here to name. So this now be 1, 2. So this compound will be count the longest chain. 1, 2, 3, 4, 5. This compound will now be pent. Now it's not going to be 1, 2, now will be pent 2 iron. Please take note. Whenever you are writing a name, between number and letter, make sure you separate them by an hyphen. This dash line, make sure you separate them. And if it is letter and letter, don't separate them with anything. And even if there is two number like 2, 2, make sure you separate number by a comma. Number to number, separate them by a comma. Letter and number, put an hyphen. Do not forget. So therefore, the name of this compound that you see here, number 4, is pent2-ine. So therefore, I have butane, I have but1 in, I have but2 in. Why this one is pent2-ine. Alright. Why the final structure that I'm having here, how do you deal with this? So to deal with this, you are going to first know that this carbon at the edge is not having CH3, it's having CH. That will tell you that there will be some bond, and then it's not going to another carbon that's also lacking, that is not having any hydrogen. And this CH2 is to be written in how many places? 3 places. So you have to write CH2, CH2, CH2. That means this CH2 has nothing to do with this carbon. That means they only supply it one bond. So that means for you to balance this, you have to put triple bond here. If a carbon at the edge is having 1 hydrogen instead of 3, that means it has lost 2 hydrogen. When you lost 2 hydrogen, it means you are an alkyne. If you lost 1, alkene. But if you lost 2, that's an alkyne. So therefore, if you count 1, 2, 3, 4 for this carbon, balance 1, 2, 3, 4 for this carbon. So this compound is an alkyne. Now, if you want to name 1, 2, 3, 4, 5, this side is too long. That's 5 ion. But if you come from the left, 1, you have seen the ion. So it's more better to come from here than from here. So therefore, count your longest chain. 1, 2, 3, 4, 5, 6. So this will be the parent name. The Greek suffix that is required there is X. So because of the location, 1 ion. Please note this. Whenever you can have a 1 ion, avoid 5 ion. Always go with the lowest number possible. In my next video, I'm going to be taking the branched hydrocarbons, whereby you have attachments with hydrocarbons, whereby you'll be having methyl attachment, ethyl attachment, propyl attachment. You know, naming organic compound is a broad field, and the more you solve, the more you know. Please keep practicing, keep naming, and you will see yourself winning. Thank you very much for taking your time to watch this video. Please don't forget to subscribe, share, and please ask me any question in the comment box. Thank you very much, and God bless you.